Welcome back, everybody. This is our ninth class in JEE previous year questions for chapter Moving Charges and Magnetism. Before this video, we have made 8 videos in this series, and all of those videos are available on our YouTube channel's playlist section. We have also started similar series for NEET previous years. So, if some of your friends are preparing for NEET, then you can guide them through that playlist, and all of those playlists are available on channel's playlist section. If you find these videos useful, do press the like button, share them as much as possible, and subscribe to our channel. Also, if you like to support us financially, then you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. However small the amount, it will be highly appreciated. So with this, let's start today's video. As I think we are around 60. Here it is. This was the last question we completed, and now we will start the next one. So here we have two long parallel wires at distance 2d apart. They carry equal current flowing out of the plane of paper as shown. The variation of magnetic field. Now, as they are carrying equal current, and that current is flowing out of the plane of the paper. So suppose this is first wire and this is second wire, and their current is coming towards out of the screen or out of the plane of the paper, then using right hand screw rule we can find out direction of the magnetic field. As for suppose this is our wire A and this is wire B, then for wire A, direction of magnetic field will be something like this. It will be in clockwise. And for wire B, as direction of current is similar in both of these, so here again direction of magnetic field will be in, oh sorry, it is anti-clock, so both, it is anti-clock in both. So we can see that on the, we can say this is left side and this is right side. So on left side, if we consider downward magnetic field as negative, so it will be negative, and on the right side it will be positive. Or what we can do, we can choose the reverse, that if we choose this as a positive field, then this will be a negative field. And now coming to the field at center, at point in the midway point, suppose this point is C, then at this point there will be upward direction field from the wire A, and there will be downward direction field from the wire B. And as both wires are identical and distances are identical, so at center the magnetic field will be 0. So we will use this one as so at center magnetic field should be 0, and in all of these magnetic field is 0 at center. And now on the opposite sides of the center, on the we can say of on the left side of this center or point C, we have magnetic field in upward direction, and on the right side of this point C we have magnetic field in the negative direction. So it means at this point magnetic field should change its direction. So here direction of magnetic field is not changing from negative to positive, so this get cancelled, and again this is also get cancelled. Now coming to these two diagrams, let us consider that upward field is positive. If upward field is positive, then here we will have positive field in this side, and in this region we will have negative field, and this will be our zero line. Now coming to here, as a downward field, so it will be negative, and here we have upward field, so it will be positive. And this type of diagram we can find out that this is the diagram which follows these conditions. So option A will be the right answer. Moving to the next question. A horizontal overhead power line is at a height of 4 meters from the ground and carries a current of 100 ampere from east to west. The magnetic field directly below it on the ground is, so we have to find out magnetic field below it on the ground, and it is a horizontal overhead pipeline, so we can consider it as an infinite conductor. And for infinite conductor we know value of magnetic field, that it is given by mu node I by 4 pi d into sine of phi 1 plus sine of phi 2. This is for infinite conductor. So here mu naught by 4 pi is 10 raised to power minus 7. Current is 100. Distance from the ground is 4 meter. And sine phi and 1 2, as it is infinite conductor, so both angles will be equal to 90 degree, and so 1 plus 1 is equal to 2. So what we will have 2, and here we will have 50. So 5 into 10 raised to power minus 6. So this will be the value of magnetic field, and now we have to find the direction, that it will be north or northward or southward. So let us consider that first make the direction. This is north, this is south, this is east, and this is west. And this we seeing this from the top, and wire you can say current is flowing from east to west. So current is flowing from east to west. So current is like this. Direction of current is this. Now using the right hand screw rule, we can say that direction of magnetic field will be something like that it will rotate in this manner. So on the top side of the wire, magnetic field will be going from south to north, and on the bottom side of the wire, magnetic field will be coming from north to south. We can say this is the head, and in the front side of this head we have south direction, and on the back side of this head we have north direction. So on the top it is going from south to north, and on the bottom it is coming from north to south. So and we have to find field on the ground. So on the lower side we have to find direction of the field, and on the lower side it is going north to south or southward. So option C will be the right answer. Now let's move to the next one. A long straight wire of radius A carries a steady current I. The current is uniformly distributed across its cross section. The ratio of magnetic field at A by 2 to A, and that can be easily solved using this formula, that we have integral BdL is equal to mu naught I. Now suppose we have a wire here, and in its radius is A. So this distance is A, and we are finding magnetic field at A by 2. So for that what we have to do? We have to make a small circle of radius equal to A by 2. So radius of this circle is A by 2. Now using this formula we mark is as B1. Field at radius A by 2 is B1 into dl. Dl is the circumference. For radius uh, A by 2 it will be twice 2 pi into radius, that is A by 2. Mu naught times the current in this circle, and current is divided by area. So total current is I divided over the whole wire, which has a cross section of pi a square, and we have to find current in the circle up to radius a by 2. So area of that circle pi a by 2 square. So from this, b1 times pi a is equal to mu naught I. A square get cancelled, and here we have 4. So b1 comes out to be mu naught I by 4 pi a. Now going to the second part, that magnetic field at a 2a distance. So now we will mark a circle with radius equal to 2a. So now we can write that b2 is equal to b2 into 2 pi of twice of the radius using the same formula is equal to mu naught times I. Now as with radius 2a we are outside of the wire, so in the outside portion there is no current and only current is inside the wire, so we will take only that current, as in the remaining part there is no current. So maximum amount of current, that is equal to amount of current in the wire. So from this, b2 is equal to mu naught I by 4 pi a, and as both of these are equal, so their ratio will be 1:1, or option D. Moving to the next one, the current I flows along the length of an infinitely long, straight, thin wall pipe. Then the magnetic field at the all point inside the pipe is same but not zero. Magnetic field is zero at the axis of the pipe. Magnetic field is different at different points. Magnetic field at any point inside the pipe is zero. Now here the important thing which is to be noticed, that it is a thin walled pipe, means it is a hollow pipe. It is a pipe hollow from the inside. So pipe is something like this. Inside it is hollow, and all the current flowing is flowing through the surface of the pipe. Now if I make a Amperian loop here inside this pipe, and in this loop there is no current flowing. So if I write equation for this loop, BDL is equal to mu I enclosed. So value of current flowing through this loop is zero, or we then means value of magnetic field is zero. So value of magnetic field inside all the points in this loop or in this pipe will be zero. And so here it is, option D, that magnetic field at any point inside the pipe is zero. Moving to the next one, two identical conducting wires AOB and COD are placed at the right angle to each other. The wires AOB carries an electric current I1 and COD carries a current I2. The magnetic field on a point lying a distance d from O in direction perpendicular to the plane of wire AOB and COD will be given by. So we have two wires perpendicular to each other. Let's draw them. Suppose this is first wire and this is second wire. Now this is A O B and this is COD. At a point lying distance d from O in the direction perpendicular to the plane of the wire AOB and COD. So our point is such that it is perpendicular to both of the planes. So we can say COD wire is in X direction, AOB wire is in Y direction, and our point will be in Z direction because it is perpendicular. Here it is mentioned, point at distance d from O in the direction perpendicular to the plane of wire AOB and COD. So it is perpendicular to both planes, means it is in Z direction, or we can say. So our point is somewhere here. Somewhere here. This is our point, suppose point P, and this distance is equal to D. Now we have to find magnetic field, and as we can see that, and I think direction of current, right angle carries current. So direction of current is not also given. So for that we can have, I think, two possible answers. But then we will choose. We will take depending upon that what our answers, which our answer satisfies. First of all, let's take that these are the direction of the currents in both of these uh, wires. Now, as these are infinite conductors, so we know that value of magnetic field will be mu node I by 2 pi d. This will be the value of magnetic field. Now, suppose this is our wire, I can say we denote this wire by A and this wire by C. So BA will be equal to mu node I by 2 pi d, and applying the right hand screw rule for wire AOB with current going in the y direction, the magnetic field at point P, which is perpendicular to the plane, will be in x direction. At this point, magnetic field due to this AOB wire with current going in the upward direction will be something like this in x direction. So it will come with I unit vector. Now magnetic field due to wire C, it will be amount will be, oh sorry, here we forgot to add I1. So here we will have I1, and in this case we have current I2, so it will be mu node I2 by 2 pi d. Distance is same, and in this case, applying the right hand screw rule, magnetic field will be in the downward direction or in J direction, negative J direction. So it comes with J and negative sign. So total field becomes mu node I by 2 pi d of I minus mu node I2 by 2 pi d of J. And if we find the magnitude we can find out, it will be mu node by 2 pi d I1 square plus I2 square whole under root, which is option C. If we change the direction of the current, just signs and direction will change, magnitude will stay the same. Moving to the next one. A long solenoid has 200 tons per centimeter. So we can say value of N is given. N is 200 and it is per centimeter. So we can say it is per centimeter. So we will convert it into per meter. It will comes out to be 2000, 20,000, sorry, 20,000 per meter. Moving to the next part. Magnetic field is given at center 6.28 10 h power minus 2. Another long solenoid has 100 tons per centimeter and carries current I by 3. The value of magnetic field at the center is. So for a solenoid, magnetic field is given by mu node N I at the center, and at the corners or at the edges it is mu node N by 2. So suppose we have first solenoid which has magnetic field B1, number of turns N1 and current I. And in the second solenoid we have B2, mu node N2 I by 3, which is given to us, and value of N1 and N2 is also given. So B1 by B2 is equal to N1 by N2 into 3. So B1 is 6.28 into 10 raised to power minus 2. Here we have B2. Value of N1 is, if we, as both N1 and N2 are given in centimeter, so we can take directly them in centimeter because units will cancel out. 200 by 100 into 3. So this get cancelled, and we have B2 is equal to 6.28 into 10 raised to power minus 2 by 6. So it will be approximately 1.04 into 10 raised to power minus 2, which is similar to option A. Moving to the next one. Two concentric coils, each of radius equal to 2 pi centimeter, are placed at right angle to each other. 3 ampere, 4 ampere, the current flowing in each coil respectively. The magnetic induction in vapor per meter square at the center of the coils. So we have two coils. Suppose this is the first one and this is the second one. They are placed at perpendicular to each other. Let's change color for that so that we can distinguish. Their radiuses are equal and currents are different. And it is not mentioned that whether current is flowing in clock, anti-clock, or one in clock and one in anti-clock. So what we do, we assume our own direction here in this and in this, like here. So this is our ring A and this is ring B. So magnetic field due to ring A at the center will be mu naught I by twice of the radius, and using right hand screw rule we can say direction of magnetic field at center due to this ring A will be upward. So direction J, positive Y direction. Now magnetic field due to second B, or we can say coil B, will be mu node, sorry, here we have to add current I1 as currents are different, mu node I2 by twice of R, radius are same for both of these. And here due to this, using right hand screw rule we can find the direction will be in negative I direction or negative X direction with negative sign. So total field will be mu node by 2R can be taken common with I1, sorry, I2, I2I, negative I2I plus I1J. And we can find the magnitude from here. Magnitude will be mu node by 2R into I1 square plus I2 square. Now mu node is 4 pi into 10 raised to power minus 7 divided by twice. Radius is 2 pi and in centimeters, so 10 raised to power minus 2. Currents are 3 ampere and 4 ampere. 3 square plus 4 square under root is equal to 5. So they cut each other and we have value 5 into 10 raised to power minus 5. So here is option D will be the right answer. Moving to the next one. Current I ampere flows along an infinitely long straight thin wall tube. The magnetic induction at point inside is, so we just solved this type of question, and as we already discussed in the previous one, that in case of hollow conductor magnetic field will be 0, So answer is option B. Now here, a long wires carry a steady state current. It bent into circle of one turn and the magnetic field of the center of the coil is B. It is then bent into circular loop of n turns. The magnetic field of the center of the coil will be. So we have already solved this type of question. I think it was question number 47. Here it is. So we got the answer as one by one n square, and magnetic field of the coil was higher, and for the loop was lower. So coil loop by coil is 1 by n square. So here we have magnetic field at the center of the coil. So we know that magnetic field of the loop by magnetic field of the coil is equal to 1 by n square, and magnetic field of the loop is given as B. So from here we can say that magnetic field of the coil will be n square times B, and option B will be the right answer here. Moving to the next one. Magnetic field due to a current carrying circular loop radius 3 centimeter on a point on its axis 4 centimeter from the center is 54 micro Tesla. What will be the value at the center of the loop? So we know that for a coil at some distance, or for a loop at some distance from its center, magnetic field is given by mu node n I into radius square divided by square of radius square of the distance power 3 by 2 with 2 here. So it is given to be 54 micro Tesla, and we can say here value of mu node is 4 pi into 10 raised to power minus 7. Number of loops are not given, so assuming them 1. Current is not known to us, or what we do, we calculate the value of mu node ni, because we have to use that same value in case of magnetic field at the center. Magnetic field at center is mu node ni by twice of the r if n is the number of loops. So we just calculate the value of mu node ni. So mu node ni into radius, that is 3 centimeter. So square will be 9 into 10 raised to power minus 4 divided by twice radius square 9 into 10 raised to power minus 4 plus that distance is 4 centimeters, so 416 into 10 raised to power minus 4 power 3 by 2 is equal to 54 into 10 raised to power minus 6. So this will be mu node ni 9 10 raised to power minus 4 divided by twice 9 plus 16 is 25 into 10 raised to power minus 4. Under root will be 5 into 10 raised to power minus 2, and cube will be 125 into 10 raised to power minus 6 is equal to 54 into 10 raised to power minus 6. Now this will go on 6, and here we will have 10 raised to power minus 2 left. So mu node ni is equal to 6 times 2 times 125 into 10 raised to power minus 2 from here, and 10 raised to power minus 6. So it will be 12 into 125, or I can say 250 into 6 into 10 raised to power minus 8. Now magnetic field at the center will be mu node ni by 2r. So B at center will be 250 into 6 into 10 raised to power minus 8 divided by twice r is 3 into 10 raised to power minus 2. So 6 get cancelled. We are left with 250 into 10 raised to power minus 6 or it is 250 micro Tesla. Option C will be the right answer here. Moving to the next one. If a circular coil A of radius R carries current I flowing in the another coil B radius 2R 2I, then the ratio of magnetic field produced by them. Okay, it is not mentioned that we have to find a magnetic field at the center or somewhere else. So we suppose that we have to find magnetic field at the center. So B1 will be mu node current is I by twice of R, and B2 for the second coil mu node twice of I by twice of R, and it is basic twice of 2R because twice of the radius. So it's basically the same value. So their ratio will be 1:1. Option A will be the right answer here. Moving to the next question. So let's slide it down slightly. A square loop of side 2A carrying current I is kept in XZ plane with center at origin. A long wire carrying the same current I is placed parallel to Z axis and passing through point 0 B0. B is greater than A. Magnitude of torque on the loop about Z axis will be. So first of all, let's draw the diagram. And we need Z axis also. So this is X axis, this is Y axis, and this is Z axis. And we have a, I can say, we have a square loop of side 2A kept in XZ plane. So loop should be kept in XZ plane, and that is XZ plane. Or what we do, we can change the axis. So let's change the axis so that we can represent it in a better way. This is our suppose Z axis and this is Y axis. So now our square loop will be here. So this here is our square loop. It is in XZ plane, and at center it might seem to you that it is at y is equal to some value. No, it is actually at the center, and we have a line touching here like this to give a better idea. We have a line here which touches this square. Now a long wire carrying the current I placed parallel to the z axis. So wire is parallel to the z axis, so means it will be going through somewhere from the y or either from the x axis, passing through 0 b0. It is written as 0 b0. So it is x, it is y, it is z. So it is passing through y is equal to b. So suppose this is y is equal to b. So wire is passing through here from here. Suppose this is the wire which is passing here, and this distance between this square loop and the wire is equal to b, because it is passing at a distance b from the center. So magnitude of the torque we have to find out. We know that torque is given by m cross b. So torque is normally given by m cross b. And so first of all, let's find out the magnetic field due to this wire at the center. So magnetic field due to this wire at the center, first of all, assuming that current in both of these in same direction. So let's assume that current in this wire is going upward, and also in this loop we assume current like this. So magnetic field due to this wire at the center will be in negative x direction. First of all, with the help of right hand screw rule, we can find the direction. And as it is an infinite conductor, so magnetic field will be B will be mu node I by 2 pi times the distance, that is B, into the direction, that is minus I. So minus I. And now coming to the so yeah, magnetic dipole moment of the this square panel or this square loop, and we know that m is I into a, so it will be I into area of this loop is, as side is 2a, so area will be 4a square, so 4a square. And direction of this m will according to the right hand rule we can take as in the, it will go into negative y direction. According to right hand rule, you can see after rotating your right hand fingers parallel to y direction or in the y direction, then your thumb will point in the negative y direction. So with rotation, the value of magnetic dipole moment will come up to be in minus j. So we can say torque will be equal to m cross b. So it will be minus minus get plus, and j cross k will be minus k, and here direction is not mentioned. So we will just write down the magnitude. So mu node I into ia square 4 divided by 2 pi b, and further we can solve it like mu node twice of mu node I into ia square by pi b. Now both currents are equal, so it will be I square, as both currents in the loop and in the wire are equal, so 2 mu node I square by into a square by pi b. And if we match the answer, we have option A as the viable answer. So with this we end this video here. Hopefully whatever we have covered here is helpful to you. Again, if you have any doubts or suggestion, you can put them in comment section. I will try to resolve or implement. And if you like this video, then do press the like button, share it as much as possible, and subscribe to our channel. Also, if you like to support us financially, then you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. Any donation of however amount it may be small will be highly appreciated. So with this, again, thanks for watching, and we will meet in next video.